Hi everybody, I'm Lucas from the Arda team. In this video, I'm going to present you xSuite. It's a tool that will be very useful for the hackathon. xSuite is a JavaScript library for efficiently building, developing high-quality MultiversX smart contracts. In particular, with xSuite, you can initialize, build, test, deploy contracts in seconds. xSuite has two main advantages. The first one is that with xSuite, you will be able to quickly develop smart contracts. It's due to the fact that xSuite comes with a very convenient command line interface, shortly called CLI. And the second thing is that xSuite proposes you some starter contracts. It's contracts already done by the Arda team and audited by the Arda team that you can start your new contract from. And so this way you save a lot of time when you start your new contract. So that's the first main advantage of xSuite, that you are going to be able to build smart contracts fast. And the second advantage of xSuite is that you will be able to build high quality smart contracts. And it's due to the fact that xSuite comes with a lot of tools to help you test your smart contract. The main thing that xSuite proposes you is first a simulated blockchain that we call SimulNet. It's a blockchain that runs on your computer and simulates the real blockchain, but it has some differences. The first one is that on the simulated blockchain, the SimulNet, the transactions run instantly, so your test will run super fast. And second thing is that the SimulNet has some administrator endpoints. It is endpoints that will help you setting the state and configuring the blockchain such that you can way more easily test weird situations or weird states, etc. And the second thing is that xSuite comes with JavaScript interactors. So basically, you will be able to write your tests in JavaScript and use the powerfulness of this language. And this way, you'll be able to make very sophisticated, complete tests of your contract. So that's the second reason, main reason of using xSuite, is that you will be able to build high quality smart contracts and very fast. In this video, we are going first to initialize, build, test, and deploy our first smart contract in just a few seconds. And second, we are going to go through a more advanced smart contract in order to show you all the different things that you can do with xSuite. Last thing before we start is that I would like to thank you, the bit.ly team, who intensively used xSuite in their projects, provided valuable feedback, and also helped draft the first version of the documentation. Also, I would like to tell you that if you need training, personal training on xSuite, please send me a message on Telegram, and then we'll be able to book some time together to help you try and understand xSuite and learn how to use it the best. And last thing, if you have any question regarding xSuite, please come in the xSuite Telegram group and ask your question there. We'll be very happy to answer them. So now let's start initializing, building, testing, and deploying our first smart contracts in just a few seconds. So the first thing is to go on xSuite website. For this, you just type xsuite.dev in your browser. Once you are on the website, you click on the Getting Started page. And there you should see all the commands that you need to execute in order to initialize, build, test, and deploy your contracts. So let's start. The first thing is that you will need to have Node.js 18 or later already installed on your machine. If you don't, you can click on this toggle and execute the commands. I won't do it in this video because Node is already installed on my machine, and I assume that most of you watching have already installed Node too. But if you don't, please run these commands. Once Node.js is already installed on your machine, then you can run the first command. So it's npm install -j xSuite, and this will install xSuite globally on your machine. So please click on this button to copy the command and go on a folder on your computer and open a terminal in this folder. And then you can just copy paste the command and press enter. It will take a few seconds and will install xSuite on your machine. So it's installed now. And then you can see that now if I type xSuite, I have a response here telling me all the commands that are available to me. So by doing this, you have just installed xSuite command line interface, or called xSuite CLI. The second step is now to install Rust. So for this, it's very simple. You will just copy paste this command here, and xSuite will take care of installing Rust for you. It's probably going to take a few seconds, but it's not very long. So now the Rust is installed on our machine. The next step is to create our first contract using xSuite. So for this, copy paste the first line and run it. Once the command has finished to run, you should see a new folder created in your previous folder. And then we'll open this folder. So we will cd into this folder. So it's the same as double-clicking in your file explorer. After this, what we are going to do is that we are going to create a wallet. So this wallet will be encrypted by a password of your choice. And so it means that anybody that will have access to this file won't be able to recover the private key inside if it doesn't know the password. So it makes it safe to store it on your machine while you don't share the password of this wallet. So for this, just copy paste again the command. The CLI is going to ask you for a password and ask you to enter the password again. If you go back now in your folder, you can see that this wallet.json file has been created, and it's there that the wallet is stored. The next step is to request some fake EGLD of a DevNet. So the idea is that, okay, now you have created a wallet, and later on we want to deploy a smart contract, but in order to do this, we need some EGLD in order to pay for the gas. But when you create your wallet has no EGLD, and so if we do nothing, we won't be able to deploy the contract because we don't have EGLD. So in order to have EGLD on the DevNet, you can use this command and execute it. Enter the password of your wallet, and then it's going to call a faucet in order to claim 30 x EGLD. And with this EGLD, it will be way enough in order to deploy a lot of contracts and do a lot of things on the DevNet. Unfortunately, it seems the faucet is actually not working. You can see funds already received. It's because I've requested twice the X EGLD. And if we open this address in the Explorer, you can see that the faucet has tried to send the 30x EGLD, but the transaction has failed because the faucet doesn't have enough funds. So yeah, unfortunately, this command doesn't work at the very moment I record this video, but afterwards I will investigate and try to make the faucet work again. So for the moment, I'm just going to send a little bit of xEGLD to this address coming from another address of mine that already has some xEGLD. So I've just made the transfer. I transferred myself 5 xEGLD. So now let's go back to the list of commands. So you should have executed this one and hopefully it works on your machine. Then the next step is to build the smart contract. So for this, just run npm run build. Then the next step is to test the smart contract. For this, run npm run test. And then the last step is to finally deploy the smart contract. And for this, you can copy paste the command here, or just run npm run interact :devnet and deploy. Enter the password of your wallet. And then the contract should be successfully deployed. So if we copy the address here and open it in the DevNet Explorer, we should see the contract deployed here, and we can see that the owner is the address I've just created. So voila, you have succeeded to initialize, build, test, and deploy your first MultiversX smart contract. The only thing is that this smart contract is really dumb. So for example, if I open it, go in the src directory and then open the lib.rs file. So if you look at it, it's not super visible right now, but if you look at it, it's a very, very dumb smart contract that basically does nothing. And now we are going to do the same, but with more advanced smart contract that's called vested transfers. And we will go deeper in the smart contract and see all the different things that xSuite has to offer. So let's go back in our folder. We'll go back a few folders in here. So I will cd into the parent folder. And here we create a new contract. But this time, instead of creating a dump blank contract, we'll create a new contract from the vested transfer starter contract. So in order to do this, just type xSuite new -- starter vested transfers, and then you can give the name vested transfers. So now that the command has executed, you should see that there is a new folder that has been created that is called vested transfer, and it contains all the code of the vested transfers contract. So let's open it in our code editor. So for example, Visual Studio Code. And let's start to investigate this folder. So the first thing to look at is the src folder, because it contains the Rust code of our smart contract. So let's open the lib.rs file. So I'm not going to explain you all the details of this smart contract. I assume that you already have some knowledge. If you don't, go on the MultiversX documentation to learn how to build MultiversX smart contracts. But maybe I will just go through the contract quickly. So it has a create transfer endpoint. This endpoint is going to create a vested transfer with a receiver and a release schedule. So basically, I could call this create transfer, give the address of somebody, and put as a release schedule that I want 50 EGLD to be sent to him in 10 days and 15 EGLD to be sent to him in 20 days. So that's the idea of vested transfer. It's the idea that you will transfer an amount of EGLD, but not instantly, and it will progressively be transferred to the user, to the receiver, in several different steps. So the first endpoint is create transfer. It creates a vested transfer. Second is execute transfer. So let's say that 10 days has passed. Now I should be able to, the receiver should receive 15 EGLD that I've sent. And in order to do this, the receiver or anybody can call this endpoint. And it will look at the amount of EGLD that the receiver can already receive and send them to him. And then we have a lot of different helpers endpoints. And the one that we have here is cancel transfer. It's a way for the sender, to cancel the transfer. And only the part that has not been sent can be taken back. And we have also a few other endpoints here. So now that we have gone through the contracts, the first thing we can do is to build it, as we did for the previous contract. So let's run npm run build. And quickly, what it is going to do is to execute the build script that is in the package.json file. So if you open it, you see that there is a build script. And when you run npm run build, it's going to execute xSuite build command. Once it's built, the next command you can execute is npm run test. It's going to test the smart contracts. And you can see that for this one, there are a lot more tests and they all passed. And so same, we can run npm run test because in the package.json, there is a test script. And this test script run vtest run command. And vtest is the library we use in order to run tests. So now maybe one thing you can do is to have a look to the tests themselves to see what happens there. So let's open the tests folder and open the contract.test.ts file. I'm going to hide the terminal. So if we go here, we can see first that there are a few imports. So the first import is vtest. So it's the library in order to run tests. And then there are imports coming from xSuite. So basically, xSuite is giving you a lot of utilities in order to interact with the simulated blockchain that we call Simulnet, and to a lot of utilities to interact with the Simulnet and also to do comparison, etc. So the first step is to initialize a bunch of wallets and contracts that will be used in each of the tests of this file. So for example, we'll start by deploying our contracts with the deployer.deployContract method. Then we will create a wallet that is the wallet for first sender. We'll create a wallet for a receiver. We'll create a wallet for a second sender, for a second receiver, etc. And also you can see that here there is a sword.start method. And it's with this method that we start the Simulnet, the simulated blockchain. So all this is going to be executed before each test. And then after each test, this is going to be executed. And basically, we are going to stop the Simulnet. And then you can see that we have a bunch of tests. And the idea is that with all these tests, we try to cover all the different scenarios possible with the contract to be sure that every scenario behaves correctly. So, for example, we could look at the first test. So the first test is a vested transfer of EGLD over epochs 5, 10, and 15. And the execute is made at epochs 4, 5, and 15. And finally, the user claims, so it means that it takes the funds out of the smart contract. And so, for example, in order to call the create transfer endpoint of our contract, so let's go back in the contract, we see that there is a create transfer. If we want to call this endpoint, it's very easy in xSuite. You just need to do sender1. So let's say we want the sender1 to call this endpoint. So we'll do sender1 dot call contract. We'll specify which contract it calls, which endpoint it calls. So in our case, create transfer. And then we give some arguments to the endpoint. So if we go back to the endpoint, we see that the first argument is a receiver and its address. So we will put a receiver there. And then we can see that the second argument is a release schedule. And the release schedule is a struct or is a type. I mean, it's a list of structs. It's a list of release milestone, and a milestone is a struct that is composed of epoch and amount. So concretely, a release schedule is just a list of structs. And so in order to do this, we will use e.list, that is a utility coming from xSuite 2, and then use e.tuple to reproduce the struct. And then use e.u64 to reproduce the u64 of Rust. So if we go back, we see that the epoch is a u64. And finally, we'll use the e.u 2000, and in this case, it will reproduce the biguint of Rust. So it's very simple here. We just put the name of the endpoint and then the arguments. Of course, we will give some value that represent the amount of EGLD that the user needs to send when he calls the endpoint. And finally, we'll provide the gas limit. And then we just need to await this, and this is going to be executed against the simulnet. And once this is executed, for example, we can use assert xlist that will check if the return data of the endpoint correspond to the expected value. And then we can do a bunch of other assertions. For example, we can check that the balance of the sender one is correct, that the balance of the sender of the receiver one is correct, and same for the contract. And we can do this for everything we want. So yeah, and then we can continue do some other calls. For example, this one is interesting. So here we are using administrator endpoint, and we are changing the epoch of the blockchain. So we are fast forwarding in 4 epochs in the future. And then after this, we call again the contract. And then after this, we do a bunch of other assertions, etc. and so on and so on. Another interesting thing that you can do with xSuite is that you can easily test the scenario that should fail. So when you test, it's important to test the scenario that should work and verify that they work correctly. It's the correct behavior that happens. But same for things that should not work, that are forbidden. It's important to test that indeed the contract forbids the forbidden things. And so, for example, in this test, we verify that in case a user creates a vested transfer with milestones that are not in the correct order, we verify that the transaction fails. So, for example, we can see that the first milestone of the vested transfer is at epoch 2, and the second milestone is at epoch 1. But this is incorrect. The epochs of a milestone should be strictly increasing, and so we can verify that it fails. So how do? We do sender.callContract. We give all the data for all the parameters needed in order to call the contract, and then we add .assert file, and we verify that indeed the transaction fails. And we can even check if the code is correct and if the message is correct too. So I won't detail all the things present in the testing library. I advise you to go on xSuite documentation to know about all the things possible. But it was just first, I decided to show you this file just to give you intuition on how things work, and just for you to see how easy it is to test a lot of different things. And because tests are written in JavaScript, you can use the full power of JavaScript. You can create your own abstractions, you can log things, etc., etc. And so I invite you to check further the documentation. So after testing the smart contract, the next thing is to deploy it. And for this, we run the same command as before. It will be npm run interact .devnet, and then the name of the command we want to run, so in our case, deploy. I will enter the password of the wallet. And here we see that this command fails. The reason is because the script is looking for a wallet.json file, but this file doesn't exist in vested transfers. We created one in the previous directory, but in vested transfers, there is no wallet.json file. So what I'm going to do is that I will go in the previous directory we created and copy-paste the wallet.json file and put it in vested transfers folder. And now if I go back in the code editor and run the command again and enter the password again, and then we can see that yes, the contract has been successfully deployed, and this time it's not a dummy contract, it's a vested transfer contract, so it can already be used on the devnet. And maybe the last thing we'll go through is, so what happens when we run this command? npm run interact :devnet deploy. So in order to know this, let's go in package.json2. And then we can see that there are three scripts here that are similar. First one is for devnet, second one is for testnet, and third one is for mainnet. So for example, if I replace devnet by testnet here, it should do the deployment on DevNet. And same if I replace here and put mainnet. If we look at the command, what it does is the following. It will run this file, this TypeScript file, and put with this environment variable already set. So it means that in this script, we can request the chain environment variable and its value will be devnet. And so it helps the script knowing for which blockchain we want it to do the action. And so now we can just open this script. So let's go in the interact folder and click on index.ts. I will close the terminal. And if we go through this file, we see that first we are importing a library called Commander. It's this library that gives us command line possibilities here. And then we import xSuite. And from this, we import env-chain. So it's the helper that look at the environment variable and decide on which blockchain it's going to call. And then we have a world endpoint. So in the test, we were interacting with the simulated net, simulated blockchain. But in this interact script, we are going to interact with a real blockchain. And so that's why here we don't use s-world, we use world. And finally, we import a data.json file. So the idea is that probably when you are going to do all this deployment and interaction with blockchain, you will want to store some information in order to use it in your commands. And so you can do this with the data.json file. You can put here all the data you want and then access them in the index.ts file and access the correct data given the blockchain you are interacting with. And so if we quickly go through this file, we see that there are 3 commands defined. The first one is called deploy. The second one is called upgrade. And the third one is called claim developer rewards. And the last thing I want to show you in this file is that if you look at the code, you should see that this code is very similar to the one we were doing in the test file. And the reason is that the simulnet that we propose with xSuite implements the same API as the real blockchain. So it means that you interact with the simulnet the same way you will interact with the blockchain, with the real blockchain. So it means that a code that is able to work with simulnet is likely going to work with the real blockchain and vice versa. And this is very convenient because it means that you only learn to interact with blockchains in general in order to write your test and your interaction with real blockchain and deploy smart contracts, etc. So it reduces a lot the learning in order to do all things related to your contract. So that was the last thing I wanted to show you about xSuite. Of course, there are more things that you need to learn, etc. And so I advise you to go on xsuite.dev, the documentation of xSuite, or to come ask me any question or to go in the Telegram channel and ask any question. But you should have already get a good overview of the powerfulness of xSuite and all that it enables you to do. And before concluding this video, I just want to show you one last thing. If you go on xSuite documentation website, there is a data converter tab here. And this data converter tab is a small utility tool that will help you convert data very fast. So for example, if I put hello, I will instantly get the hex value of the string I just put here. I can also create another converter, go in the opposite direction if I want. I can change the eggs, for example, and get the string that corresponds to it. I can close this one. I can reorder if I want. And also I can change, of course, the type of the input and the type of the output. So for example, I will close this one. I could say, okay, as input, I put a string, but as output, I would like, for example, a base 64 thing. And then I will get base 64. Or for example, I could say, as input, I put a big int. So hello is not a big int, so it doesn't work, but I could put a big int here. And you will get a base 64 as output. Or you could decide to put eggs also. So that's a very, very convenient tool when you build, and it will likely save you a lot of time during the development of your smart contracts. So for the hackathon, I really advise you to use xSuite because it's a tool that will save you a lot of time and also help you to build high quality smart contracts very, very quickly. And of course, if you have any question, as said, please send me a message. Or if you need personal training, please also send me a message. We are here to help. And we'll be very happy to see all the things that you are able to build with xSuite during this hackathon. And all this said, now I wish you a very great hackathon and hope you will build a great thing and win a big prize. See you!